Hello, I'm Lo. I'm solving problem number 36 on page 192. So the questions. Two children are playing a game with they try to hit a small box on the floor with a marble fire from a spring-loaded gun that's on the table, and the box is 2.2 meter away from the edge of the table, and one of the kid compressed the spring 1.1 centimeter, but the center of the marble falls 27 centimeters short of the center of the box. So here's the questions. How far should the other kid compress the spring to score a direct hit? So these are what we have been given. The distance between the edge of the table and the center of the box, which is 2.2 meters, and how long did the first marble travel, which is 2.2 meters, minus 2.27 meters, which is 1.93 meters, and how much did the spring got compressed by that try, which is 0.011 meter. The energy of the system here is the energy stored in the spring, which is energy initial equals kx squared over 2, where k is a force constant of the spring and x is the amount of compression of the spring. When the spring has returned to its natural length and has given the marble a speed, then the energy of the system will become EF equals mv squared over 2. If we can neglect fiction, then mechanical energy is converted during this fire, so that EF equals EI, which gives us kx squared over 2 equals to mv squared over 2. By doing some algebra, we will get that v equals xc1 times square root k over m. And we already know that xc1 equals to 0.011, so which will become v equals 0.011 meters times square root k over m. So the velocity times will get you the distance that an object travels, which in this case is 1.93 meters. And now we heading into step 2. So our step 2. Let's suppose that the other kid compresses a spring by an amount xc2, so that the marble is a given speed of v2. As before, we have EI equals k times xc2 squared over 2, and EF equals m times v2 squared over 2, and VI equals EI equals EF, and k times xc2 squared over 2 will equals m times v2 squared over 2, which will give us v2 equals xc2 times square root k over m. Then again, this velocity times equals the distance, so v2 times t equals x, and then this is what we given, the distance between the edge of the table and the center of the box is 2.2 meters, so v2 times t equals 2.2 meters. So for our step 3, the 4 equations on the left are the equation we get from our previous steps. Let's divide v2t over vt, which will give us 2.2 meters divided by 1.93 meters, which will give us 1.14. So let's divide that again, but this time the t will get cancelled out, which will give us xc2 times square root k over m divided by 0.011 meters times square root k over m, which will give us xc2 over 0.011 meters. Since v2t over vt equals v2t over vt, we can say that xc2 over 0.011 meters equals 1.14, and it is just in simple algebra now, so that xc2 equals 1.14 times 0.011 meters which gives us 0.0125 meters. So the answer is 0.0125 meters, which means that the other kid have to compress 0.0125 meters of the spring in order to get a direct hit.